Hello everyone! In this video, we are targeting the strain. You have already looked at how different specimens can be compared in terms of stiffness and strength. You have also seen how different materials can be compared by selecting specimens with different dimensions. However, there's a better approach than this one to compare materials. This involves taking into account the length and the cross-sectional area of each specimen that is used. So let's open the specimens tray and select the thin specimen of steel, and let's close the tray. The first specimen is twice the length of the second one. Let's select a graph and stretch the specimens using the load slider. Look at the load extension graph as we are loading the two specimens. When the load is 14 newtons, what are the extensions of the two specimens? Well, for the shorter specimen, the extension is 10 millimeters, and for the longer specimen, the extension is 20 millimeters. What two things are the same for both the specimens? Yes, the load and the fractional increase in length, since the first one is twice the other, so their extensions are also doubled. Since the strain is equals to the extension divided by the original length, let's click on Definitions and see the illustrated explanation for the strain. So the strain is defined as the fractional increase in length of an object caused by a load. In order to calculate it, strain is equals to extension divided by the original length. So as shown in this figure, this is the original length of the specimen, and after subjecting it to a load, it's extended by a few millimeters. So this is the extension, and the strain is equals to this extension divided by the original length. The strain has no units, since the extension and the original length has the unit of length. For example, millimeters divided by millimeters results in no unit. But it is often shown as a percentage. Now let's return to the workstation. If the shorter specimen has an original length or an unstretched length of 40 millimeters, what is the strain when the load is 40 newtons? Using the formula, strain equals extension divided by original length. So what's your answer? So the strain is equals to 10 millimeters divided by 40 millimeters, which will give 0.25.